Yellowstone National Park is one of America's great playgrounds. Millions of tourists visit every year to walk the boardwalks and photograph the vibrant geothermal springs. But those springs are powered by something much larger. Yellowstone lacks a traditional cone volcano peak, sitting instead above a massive, collapsed underground caldera. Beneath the park boundaries, this immense chamber holds thousands of cubic miles of magma. If the crust fractured today, the surface would violently crack open. Within seconds, a dense column of pulverized rock would blast into the upper atmosphere. The global response would be instantaneous. Air traffic controllers would ground commercial flights nationwide, and breaking news alerts would flash on millions of screens. This sudden collision between a prehistoric geological event and modern human infrastructure creates a fascinating stress test for our world. High-altitude wind currents would immediately catch the ash plume, driving a massive fallout zone eastward across the United States. As it spreads, visibility drops near zero, closing major highways, while commercial airspace shuts down entirely. The national power grid faces an even heavier physical burden. Thick ash accumulates on exposed infrastructure, shorting out electrical transformers and snapping transmission lines under the sheer weight. Millions of people would suddenly find themselves in localized blackouts. With highways impassable, standard supply chains for food and clean water would simply stop moving. The immediate threat of a modern super eruption comes from the total paralysis of our transportation and electrical networks. We often think of volcanic ash like the soft, flaky residue left in a fireplace, but they are completely different materials. This microscopic image reveals volcanic ash consists of jagged, irregular shards of pulverized rock and glass. When ingested by hot jet engines, these shards melt and fuse to turbine blades, while abrasive edges grind down internal moving parts. For humans, inhaling these sharp glass particles tears at lung tissue. Regional air quality would plummet to highly dangerous levels. Emergency services would have to mount a massive, continuous operation, distributing specialized filtration masks and clearing critical access roads to protect communities from the fallout. A supervolcano dismantles civilization at the microscopic level through weaponized, abrasive dust. Weeks after the initial blast, scientists in orbit would track the most far-reaching consequence of the eruption. Massive quantities of emitted gases, specifically sulfur dioxide, rise into the stratosphere and wrap around the entire planet. This semi-translucent layer acts like a global mirror, intercepting incoming solar radiation and deflecting it straight back into space. Deprived of normal sunlight, global temperatures drop, triggering a volcanic winter. This cooling disrupts precipitation patterns and shortens the growing seasons that sustain agriculture. A single geological event originating in Wyoming possesses the leverage to dictate the climate of the entire planet. Returning to the present day, Yellowstone is one of the most rigorously monitored patches of land on Earth. Multi-agency teams gather continuous seismic and thermal data from the caldera, giving emergency management personnel predictive power to detect warning signs years in advance. Geologists agree that a Yellowstone supereruption is incredibly unlikely to occur in our lifetimes. Running this thought experiment shows us the deep, fragile connections tying Earth's geology to our human infrastructure and the atmosphere. Modern science gives us a powerful warning system, but if you had one day to prepare for an event like this, what would you do? Let us know down below.